Okay, so yeah, today we're gonna be doing another life work. Where today we're gonna be doing polymer. Yeah, this is practice problem L from the MITOCW 3.3.091 course. And so yeah, I hope that I can actually just finish this because because I just recently just learned about this. So yeah, without further ado, let's just actually just go and just dive straight into it. Here we go. There we go. Okay, so first things first here. Um, why do branch chain alkanes ha have lower melting points than straight chain alkanes of comparable molecular mass? Um, so yeah, basically that it states that the more branches, the lower the melting point. And yeah, according to my logic, the melting point is it it is related to the IMF, the intermolecular force, which means that which means that I need to find out what is the correct um assumption because um well yeah alkanes are actually just only just C's and H, but yeah, those C and H's doesn't have any double bonds. They are they are they are all single bonds. So yeah, that would mean that according to my logic, um, yeah, the more branch. Oh wait, no, actually, a lower melting point. That means that it has a lower freezing point, which means that, for example, yeah. Let me just actually just look through my notes first. Where is it? That's about X-ray. I need I need to find something about phases. There it is. Phases here. Oh, my this is some of my old notes that I have here. So yeah, I am I am just look I am just looking around. Uh, we got ethylene. Okay, there we go. I believe this is about phases. Um, okay. So yeah, this guy here only has London because it is because it is only carbon and hydrogen. It might have some dipole moments, but yeah. Oh, but yeah, I believe that London London is the one that is actually just affecting this. So let's see about phases. Um, yeah, this is basically van der Waals. Okay, stronger London literally means a heavier atom or a greater surface area. And for for branched stuff, they normally have higher surface area rather than just a single string. So basically I would say that the surface area is larger, which means that the IMF will be stronger. And that means that it will have a lower melting point. Wait, a lower melting point. Does that? Oh wait, wow. Like oh the wording is actually like a very. It is pretty. It is pretty confusing. Confusing to me as well. So I am just reading this again, just in case I might get something wrong. Um, the PV would the PV relates to the IMF. The the PV would also relate to the temperature. That means that the IMF would relate to the temperature. Yeah, that's true. I guess that is. Wait, higher temperature means higher pressure. Yeah, that's true. That means that higher P would mean higher IMF. Yeah, I guess so. And so yeah, basically, yeah, that that would be true. Have lower melting points. Does it have a lower melting point? The temperature would be. The temperature should be higher though, isn't it? I don't know. Like yeah, oh, like yeah, the wording is like yeah, pretty confusing because like yeah, sometimes that lower melting point literally means that yeah, it melts later on. A higher, well yeah, higher. Oh wow. But yeah, I believe that that's the answer. uh, so yeah, that would be the first one. Let's see here. Um, okay. Uh, Let me just search. Does a stronger IMF results in a lower melting point? Stronger intermolecular points interaction results in a higher melting point. So yeah. Oh wait, what? All of the same principle apply. Stronger intermolecular interaction results in a higher melting point. Hmm. Um. Actually, if you are just considering uh the one that has a pretty similar mass, that would be hard to imagine. But yeah, four. Well, yeah. There has to be something to do with the surface area, but then the surface area is all hydrogens, though. Huh. Wait, what? Uh, that doesn't make sense. Okay. Uh, I have no. Oh, why do branched? Huh. Un okay. An error just occurred. Okay then. I guess that's that. Let me just try to sign in again. Wait. So yeah, density and polymer properties. Let's hope that I can actually answer this one. Well, actually, um, I need to grab my book first. So yeah, I'll be back with you guys later on. Let's just pause this guy first. No, just mute myself first.
Well, yeah. Unfortunately, that's bad news because, yeah, I don't bring my book back home. Ah, that is, that is, that is just frustrating. So, yeah, uh, I'm gonna need to search on Google then. Well, let's see. Um, oh, oh yeah. Actually, yeah, that's true. So, yeah, even though that, yeah, the IMF is stronger, but yeah, this thing this thing doesn't talk about the surface area. Instead it instead it just talks about how easily it is to pack. So yeah, the branched ones are harder to pack, which results in a lower melting point. So yeah, that that's something. And yeah, their neighbors are actually much more lesser. So yeah. Um okay, so yeah, let's just do number 2. Polyethylene exists either as a linear straight line polymer or as a branched polymer, which is the high density form. Um, the higher density form would be the single line because like yeah, the single line would actually pack much more nicely than a jumbled up one. So yeah, that's basically the logic. Um, so yeah, um, higher branched results to lower energy. No, lower density. There we go. Um, or as a branched polymer. Hmm. Where is it? This one? Um, or as a okay. Which is the high density form? I think the answer should be correct using my own logic. Hmm. Is it this one? Let's see. Okay, okay. Yep. So yeah, next one. Part B. In visible light, HDPE is opaque, while low density polyethylene LDPE is transparent. Explain. Ooh. High density polyethylene is opaque. Why? Mm, I was I was first thinking about energy levels, uh, but yeah, I don't think so. Mm, well, yeah. According to Google, HDPE would have a higher interface. No. HDPE, um, they have some degree of crystallization. Okay, which which makes it into a. Oh wait. So yeah, with HDPE, that yeah, the light would be scattered. That means that it would be a white colored instead of passing through. Okay, then I guess that's the answer. Which form of PE is mechanically more flexible? Um, I would say LDPE because normally because like yeah, well because like yeah, for the branch one they could be tangled up, which means that they could which means that they could have a harder part. Then which form of PE has the higher melting point? The higher melting point is HDPE. Huh. I guess that's that HDPE. But high density. Oh yeah, yeah. Oh wait. Oh wait, no, sorry, never mind. LDPE. Oh, actually, yeah. L. Oh, like yeah. For the branch one, like yeah. I don't really actually know. So I literally need to try to review this again. Oh well. I guess I need to just to go ahead and just teach myself. Oh hey, Jack Bell, it's been a minute. Do you, do you help people study for upcoming calculus exams? I have school. I have to go. Sorry. Oh, okay. So yeah, Jack Bell. Thank you very much for actually for this comment. Actually, yeah. Do you help people study for upcoming calculus exams? Um, I will. I will try to help you. So yeah. Oh, so yeah. You can just contact me anytime, and yeah, I will be happy to help you. So yeah, thank you. So yeah, thank you very much for Jack Bell. Okay, so yeah, so yeah, Unfortunately, that yeah, my knowledge about polymers is totally busted. So yeah, that means that I need to review again and whatsoever. Uh, okay. Okay. Show how the following monomers can be polymerized. Um, it can be like yeah. Oh, like yeah. According to my intuition, like yeah, the carbon there with the oxygen, that is a double bond, which is easily separable. That is my first intuition. Or maybe like the OH with the OH could actually just bond together just to form H2O. Because like yeah, the OH could be knocked out and then the other H would be knocked out. So yeah, that could be the solution. So yeah, I guess that's the solution. So yeah. So yeah, it turns out that yeah, I don't know a lot about chemistry, but yeah, this is so yeah, this is the place for me to actually to study as well because I am also trying to explain this to others. But yes, unfortunately, I don't have the knowledge. So yeah, I need to review a bit more. So yeah, but yeah, for maths, I I normally have the have I normally have the knowledge to do those things. So yeah, that basically states that yeah, that's why I got the Joe Math from. It is not like Joe Chem, which means that yeah, Joe Math with chemistry, or yeah, or or maybe Joe Fe, which means that Joe Math with Joe Math with physics. So yeah, that's why I just choose Joe Math. So yeah, also yeah, so yeah, for this guy here, um, these guys here can't actually just bond to each other to form H2O, while while this bond actually transfers there, and so that would actually make it into a condensation, polymerization. So yeah, that is basically my knowledge. Yeah, the only thing that I know is about how do you form polymers. But yes, I don't know about the properties from their micromolecule because like yeah, my knowledge is not that enough. So I just need to improve. So yeah, let's see here. Show how show how how show how ethene can be polymerized using radicals. So yeah, that's basically just addition. Simple addition. Okay. So yeah, that's basically that. Um, let's go to the next one here. There we go. Relative boiling points. Why do aldehydes and ketones have higher boiling points than alkanes or alkenes of comparable molecular mass? How is increasing the mass of aldehyde of ketone is going to affect its melting point? Compare boiling point of carboxylic acid to similar mass alkanes and alkenes and explain the physical reasoning for the difference. Wow, 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 wow. Okay. Uh, I don't have the knowledge. So yeah, I really need to learn more about polymers. Oh wow, aldehydes. Oh wait, no, actually, why aldehydes and ketones have higher boiling points than alkane and alkenes of comparable molecular mass? Uh, have much more boiling point than the alkenes. This is attributed to the dipole moment of carbonyl groups. So this basically states about dipole moment of carbonyl groups. Carbonyl group. What does that mean? Radical with another radical? Okay. So aldehyde
are okay ketones. Oh yeah. Oh like yeah. From like yeah from my from my observation of the structure, it is true that yeah, aldehydes and aldehydes and ketones actually have dipole moments instead of alkenes, and alkenes which doesn't have any dipole moments. So yeah, I guess that's that. How is increasing the mass of aldehyde of ketone is going to affect its melting point? Well, yeah, because of one thing, obviously, and that's from the London stuff. London stuff. Compare boiling point of carboxylic acid to similar mass alkanes. Okay, carboxylic acid. I don't know about that. Because like yeah, all of my all of my all of my uh all of my chemistry names, all of those orga, I still don't know what they are called. So yeah, this is basically the best point to learn. Carboxylic acid is a radical with a carbon attached to an O and an OH. Um, it should be similar. Like yeah, the similar to aldehydes and ketones. So yeah, that's my knowledge. I hope that helps. Uh, and yeah, and then lastly, we actually have problem 6, which is on the book of Shackelford, which I got free. Calculate the degree of polymerization for a low density polyethylene with a molecular weight of 20,000, a high density polyethylene with a molecular weight of 300,000, and an ultra high molecular weight polyethylene with a molecular weight of 4 million AMU. Okay. Uh, Unfortunately, I don't know about those polyethylenes, so that's why I have this book here. So yeah, I can actually just read this as well, even though that it doesn't make sense to read when you are at live. But yeah, I guess this should work. Uh, let's see. Where is the PE, and others? That's glass fibers, composites. There we go. Okay. There we go. Uh, huh. I have found something about AMU, but I don't understand. Okay, there we go. LDPE, HDPE, and UHMWPE. Wow. I still don't know what they are all about. Actually, I'll just actually do that later on. Because my knowledge is very small, so that's why I need to just try to figure this out. Uh, but yeah, I think I'll just do that later on because basically everything on the book is something that I haven't actually read. So yeah, I guess that this is the live stream. I'm I am so sorry about this shortage of knowledge. This would mean that I need to review again and hope that I could actually just answer your question on the next live work.
Oh wow, my like yeah, my brain has been hit. But yeah, by the way, this channel is not about how correct it is, but yeah, instead of about how do you actually think. So yeah, I guess. So yeah, I guess I want to say thank you very much for watching this stream. Thank you very much to Jack Bell, and yeah, I'm so sorry if I don't have the knowledge to answer the question, but yeah, and yes, for for any of you, um, you can just try to, no sorry, you can ask me about anything about maths because yeah, I excel at maths. So yeah, thank you very much, and yeah, Jack Bell. Um, I will be checking my Discord just in case. But yeah, I will later just make a. I will just try to make a Discord community community just to ask about these questions, and yes, and yes also to discuss it on a live work. So yeah, thank you very much, and I'll see you guys later. Goodbye.